Okay, hello everyone and welcome. Hopefully you can see my screen okay. My name is Joyce Mulvaney and I'm the Communications Manager for the Reading Municipal Light Department. And welcome to our Air Source Heat Pump 101 webinar, which we're putting on tonight with our heat pump partner, Abode Energy Management. We'll go ahead and get started. Okay, so just a few kind of quick housekeeping items before we get into the meat of the presentation. The session is being recorded, so it will be posted on YouTube. We'll also have it on the RMLD website for viewing later. For those of you who are watching via the webinar, you can enter questions into the QA box on the right-hand side of the screen, and we'll stop periodically for questions. Also, for those viewing the webinar, we have, just to point out, there's a pause play functionality at the bottom of your screen. So if you need to get up and you want to pause it and resume later, you're welcome to do that. Just be aware that if you do that and you submit a QA, you might not end up in the same place in the presentation as us. So just something to be aware of. The presentation is also being aired, broadcast on Reading Community Television and Wilmington Community Television. So we thank them for doing that. If you did register for the webinar, you'll receive an email probably towards the end of this week with a link to the recording and some additional resources. Okay, so as far as what we're going to go over tonight, I'm going to start off by talking a little bit about RMLD. I'll pass it over to my colleague Sean, who's going to talk about electrification and some of RMLD's efforts in that area. Sean will also talk about our heat pump program, which includes our rebate, and then our partnership with Abode and the resources that they provide to our customers. We'll stop for questions there. We'll then pass it off to Abode, who will introduce themselves and their organization, and then they'll talk about the technical side of heat pumps, how they work, the configurations, some of the costs, the benefits, etc. We'll then stop for questions again, and then we'll wrap up with some additional resources and next steps. So just a little bit of background about RMLD for those who may not be too familiar or may be new to the area. We are a not-for-profit, municipally owned electric distribution utility. We were established in 1894, so in 2019 we actually celebrated our 125th anniversary. We serve a population of about 70,000 people in Reading, North Reading, Wilmington, and Lynnfield Center. So it's about a 51 square mile area, and we have about 29,000 meter connections. We're governed by a 5-member board of commissioners that's elected by Reading voters. And then there's a 5-member citizens advisory board that's appointed by the towns we serve, and that board makes recommendations to the board of commissioners. Those meetings are open to the public, so if you're interested in attending any of them, they are posted on our website. They're currently being held virtually due to the pandemic. To give you a little bit of background, just as far as why RMLD provides some of these programs, the rebate programs that we're going to be talking about tonight. So we offer these energy efficiency, conservation, and electrification programs to our customers to increase awareness and accelerate the adoption of practices and technologies that provide several benefits. The benefits include helping you, our customers, use energy more efficiently in your home or business, reducing RMLD's electricity usage during expensive peak demand times. And for those of you who are familiar with our Shred the Peak program, you know a little bit about that. To help the environment by reducing carbon emissions, and then increasing electrification within RMLD's service territory. And Sean is going to talk about that a little bit more in the next couple of slides. And our rebate programs are funded by the energy conservation charge on customers' electric bills. Okay, so I am going to pass it off to Sean now.
Great, thanks, Joyce. I'm going to spend a few minutes talking about what electrification is and what RMLD has been doing, and kind of give a high-level view and information about our air source heat pump, which is the real reason we're here tonight. So what is electrification? Electrification is a strategy for moving the fuel sources of the equipment we use in our homes and our businesses away from fossil fuel towards electricity. So why are we doing this? The last, probably 30, 40 years, there's been significant strides in making more and more energy efficient equipment that's fueled by fossil fuel. But this really goes down to also reducing carbon emissions, a whole climate change, and looking at it on a very aggregate basis across all fuel types. Some examples have included, I think one of the things we're most familiar with, certainly you see it in the news, you see it around town with charging stations, are electric vehicles. There's also been tremendous strides in the industrial manufacturing area of converting, changing some of the equipment that's used in production to electricity sourced equipment. And then heat pumps. Heat pumps are probably one of the fastest evolving and certainly growing in terms of adoption in two different ways. One for space heating and cooling, and also for water heating. Next slide, please. So what has RMLD been doing? Well, certainly our longest standing electrification program has been our EV charger rebate program. Rebates are given to customers who install their level 2 charging stations. It's open to both homeowners as well as businesses throughout our service territory. Last April, we launched 2 new programs, our electric panel upgrade rebate program and our cordless electric yard equipment program. The panel rebate program, if you start to think about it, as we move more towards electrification, many homes are going to need to increase the amperage that's in their home to serve, whether it's their EV charger or the heat pumps, or whether it's the batteries to charge up the next program, the cordless yard equipment. So we offer a rebate. It depends on how much, whether you're going from 100 to 200 or 200 to 400 panel, to do that, to help support that. And that's open to all our residential programs, or customers rather. Our cordless electric yard equipment rebates a variety of items, from hedgers to lawn mowers to riding lawn mowers. And we're really targeting residential customers as well as commercial customers, because one of the things we're seeing is there's been a pretty quick and growing development on having more and more electric commercial grade yard equipment. So that's something we're certainly going to see over the next few years. Next slide, please. So I touched on this in the previous slide where we talked about the heat pumps. RMLD now has a standalone heat pump for water heater program, to which we give a $500 rebate for customers who install Energy Star rated systems within their home. And then we have various level rebates, and we'll talk about this in more detail, for the airsource heat pump program. And that's what we're going to talk about in the next few slides. So what is RMLD's heat pump program? We started it in earnest, I'll say, last April. We've had it in as part of our suite of our appliance programs for the last several years. But last April, we wrote this out as a standalone program. And the reason for doing this is we really wanted to highlight and give more attention to this particular type of technology, make customers and contractors more aware of the technology, the benefits from doing that, not just from electrification, but also for helping to manage fuel costs for customers, both on the residential and the business side. And we wanted to make sure, as part of this education process, that both contractors and customers understood how these systems should be designed and sized so that they could produce the optimal comfort and, again, produce the savings that we're talking about. Next slide, please. So what have we seen so far for this program? Well, last April we thought we'd probably get about 30 to 40 heat pumps beginning in April, by the end of the year. Well, to date we have almost 130 applications. Tremendous number for what we, compared to what we expected. Some of this was driven by, the pandemic. More homeowners are home thinking about how they use their space, taking the time and the money that they might use for other purposes and investing in their homes. The other piece of it I really really think stems from a growing awareness and education, certainly that RMLD is trying, but also throughout, the marketplace. More and more contractors are very familiar with heat pumps. That information gets disseminated to customers when they're making their decisions as to what type of equipment to replace. Next slide. So RMLD's heat pump program, it's fairly broad in the fact that the systems that are eligible for rebates include both central heat pump systems, ones that serve their entire home through a central mechanism. We also provide rebates for mini splits, and these are mini splits that can serve a single zone, like you might install in a great room or something like that, or multi-zone, a mini split that you might have several air handlers within your home to serve different parts of your home. And the rebate structure for someone who is installing an air source heat pump that did not have one before, which is truly the bulk of what we've been seeing in the marketplace, is $1,000 per ton. If there is a customer who has an existing heat pump and it has reached the end of its useful life and they want to replace it, we also want to provide an incentive to them to help encourage them to continue to use that type of technology, and that's $200 per ton. And then the third type of rebate under this program is for integrated controls. And what integrated controls are is they're a technology that can be installed in homes where the homeowner or business does not remove the existing heating system. And so what the integrated controls do, it's not just a programmable thermostat, it's even smarter, if you will, than that. It is actually connected to both of your systems, and it looks at what the temperature differential is between inside and outside to determine which system really needs to operate. Is it more efficient to operate the heat pump, or does it make sense to use the existing system there? So again, we're trying to achieve some optimization and really maximize the cost savings for the homeowner or business owner. So integrated controls help us achieve that. Next slide, please. So one of the things that as we unrolled this program and started talking to contractors and to customers is we really wanted to provide some more in-depth technical assistance to both contractors and customers. So last October, we partnered with Abode to provide these types of services. And the idea here is to provide the education and also help to make sure that the equipment that's being installed is installed properly and meets the needs of it, but also to help answer questions, whether they're questions from contractors about different designs or whether they're questions from homeowners about, well, geez, does this make sense for the type of home I have and what I want to kind of do in terms of comfort levels. So this became our partnership last October. Next slide. So as part of the suite of services that Abode offers to our program, there's some services, we call them optional resources, but Abode has provided us with a heat pump specialist. This is a person who is available to RMLD customers to answer questions about, gee, should I put in a heat pump? Does it make sense? My house looks like this. It's 2 stories. I have a lot of small rooms, or I have a very open floor plan, really to provide that kind of information. Also, too, homeowners can come to contact the heat pump specialist, schedule an appointment, sit down and say, hey, I've talked to 3 different contractors. I'm not sure I really understand the 3 different bids. What makes sense? We're not, and they provide an objective third-party review of that. They're not going to identify which ones a homeowner should go to, but really lay out the pros and cons to that. The other resource that Abode has provided is to develop a participating contractor list. And this is a list of local contractors who have been vetted in terms of the type of qualifications that they have, the type of heat pump trainings that they have, and also they've gone through an onboarding process to understand all kind of the nuances and the requirements of RMLD's program. So there's a list. So when customers say, hey, are there contractors I should contact, they can refer to that list and select one. Or if you have an existing contractor that you've used over the years, you're certainly welcome to do that. You're not required to use it. It's just another kind of assistance and step to help with homeowners and businesses. We do have 2 required steps once you get past that point of saying, okay, I've selected the contractor, I'm ready to go. And these next two steps are really Abode working closely with the selected contractor in 2 phases. One is the pre-approval. In this process, Abode works with the contractor to make sure and review what's being specified. Is it the right size unit, the right design, the right configuration that's going to generate those expected comfort goals as well as cost savings? Is it going to be sized correctly to operate in the optimal way? The next step is really post-install. So once you're pre-approved and the form is filled out and been reviewed, then it goes to the installation. And after it's installed, then the contractor comes back and completes a post-installation QA form. And that is to verify that the system was installed properly. For example, was it installed high enough off the ground to, protect it from drifting snow? Collects photos and other documentation that's required for the RMLD rebate process. So those are the 2 required steps, but we also have some other resources too that can help throughout the process when there's questions. Next slide. So how is this working? Of course, we're a little bit biased, but we have been very happy with how this has worked, and so, from the customer perspective. Because of the ability for customers to engage Abode throughout the process, whether it's just learning about it, whether it's the installation phase or the follow-up, has really been helpful from both the homeowners and the businesses that have participated in the program. And so these are just a couple snippets of feedback that we've gotten. So with that, I'm going to pause before I turn this over to Travis Estes from Abode and see if are there any questions that have come up or.
Yes, there are a couple questions here. So the first one is from Charlie, and it's, are the rebate applications for whole home conversions or just single systems for spot heating or cooling?
It's for both. So it can be for the whole home, or, we've had a number of participants that have, done an addition and they just wanted it to serve that area. So both of those.
Okay, and then another question here. So is the program just for air source heat pumps or also for ground or water heat pumps as well?
Right now, our program is only for air source heat pumps. The other technologies are things that we're going to be considering later this year, but right now we're focusing on the air source heat pump.
And then the last question for this session here, about how long it takes to review applications. So someone had their application reviewed by Christopher from Abode earlier in January, and they're wondering how long it will take for final approval.
Well, given the numbers that we've had through the program, they're a bit unprecedented in terms of the number of applications. So that process has been a bit of a slower process than we'd like. So we've actually made some changes to our program to help shorten that length of time from the time that the paperwork gets completed until the time that they get the rebate check. So the key there is to make sure when the paperwork goes in that it is complete, because most of the delays in getting it reviewed is, someone forgot an invoice or something like that. So that's really the critical part, to make sure that you have all the pieces there going in to save kind of the back and forth to that.
Okay, actually we have a couple more questions here. So someone installed a heat pump in a mini split system in October, and they're wondering if it's too late to apply.
Unfortunately, it is effective January 20th. The pre-approval and post-installation are 2 required elements to the program. So we're happy that someone has installed the heat pump, but from a program perspective, effective January 20th, any applications received after that have to have those 2 steps completed.
Okay, and then where can participating contractor lists be accessed?
There's a link on our website, rmld.com, and then go under programs. And then for the heat pump program, you can get that information. I believe that's also on the Abode website as well. There's links between the two, both Abode and RMLD.
Okay, and then how quickly does the rebate itself happen after the job is complete? And have you found that the contractor will work with you or wait for the rebate check? So, okay, this question's about whether the check's going directly to the contractor or to the customer, and again, how long that can take.
So the rebate check is paid directly to the customer on record, so and not to the contractor. Contractors and Travis and Christopher will speak a little bit to this. They've been very cooperative in terms of working with us. There really have not been any issues in terms of them, delays or whatever. They're very much been very participatory in this process.
Great. Okay, so it looks like the next couple questions here are quite technical about specific questions about specific heat pumps and how they would fit in different houses. So maybe we'll save those for the second round of questions at the end of Abode's presentation.
That sounds great. So with that, I'm going to turn it over to Travis, who's going to kick it off and talk about Abode and Abode's role in this program.
Great. Thanks, Sean, and thanks all at RMLD and all the residents and customers that are joining us this evening. So just as a quick way of introduction and background, my name is Travis Estes. I'm head of operations here at Abode. We are a Concord-based business, so we're here in Massachusetts. I actually live in Reading myself with my family and 2 kiddos that go to schools here. So this is my community, and we're really excited to be working with friends and neighbors on this program. As Abode, we provide community heat pump programs for 8 other municipal light plant communities around the state. And since launching this program last year, we've connected with nearly 300 households to help them learn more about heat pumps. And we've conducted technical reviews on well over $1 million worth of projects just in the last handful of months alone. So we're seeing a lot of volume and working with a lot of contractors and residents throughout the state on these programs. We don't sell heat pumps, and so that's one big clarification that we like to make. We used to be contractors ourselves in homes working with residents in a variety of capacities, but now we are purely a third-party objective team that is providing advice to customers, contractors, and utilities around clean heating and cooling solutions, among other efficiency needs. We also oversee a large portion of the Mass Save program on behalf of National Grid. Specifically, that is the residential customers that are using home performance contractors to access the no-cost Mass Save energy assessments and incentivized weatherization benefits. And we also do work with Eversource in Connecticut on their virtual pre-assessment program. Next slide, please. So just briefly here, you can see many of the clients that we work with throughout the state. One of the things that I want to note is that particularly with the municipal light plants that we partner with, many of them look to RMLD as an example of innovation around incentive programs that are helping residents make efficiency improvements, whether that's on heating and cooling systems or the EV adoption and other electrification technologies. So it is really exciting to kind of continue to help RMLD and be a partner in this in a way that is not only supporting our community here, but is really serving as a model for many other communities across the state. Next slide, please. And so our background as contractors, as program administrators, utility consultants, and as lead vendors, that gives us a unique perspective on the goals of each of these different stakeholder groups. We're also customers in these programs. Personally, I've used RMLD's incentives when installing an airsource heat pump, a heat pump hot water heater, and an EV level 2 charging station in my home. So we are aware of kind of the challenges that folks can face in programs that have specific requirements, as well as working with contractors to meet those requirements in these processes. Being able to evaluate every situation with each of these lenses is what really gives us the ability to support folks throughout the project. Just as a quick snapshot, this is our VP of Operations doing a deep energy retrofit on his own home a few years back. So not only are we passionate about this during the day, but also on our nights and weekends as well. And next slide, please. So just briefly, as Sean mentioned earlier, one of the biggest ways that Abode can help residents is through the no-cost consultations that are provided by RMLD through Abode. During these consultations, we'll work with you to understand your goals, motivations, and your home's needs so that we can help you make an informed decision with confidence. Through these consultations, we're happy to cover whatever your needs are, whether that's a general conversation about what heat pumps are and how they work, or if you actually need direct support on evaluating multiple bids, we're happy to help in any capacity. At the end of the day, we want you to be prepared to move forward with heat pumps with a contractor of your choosing, if it makes sense. And the upfront advice that we provide is intended to be a starting point for most folks. As your contractor that's going to be in your home, taking real measurements, doing load calculations, and assessing the site conditions, are really going to be best situated to properly size and design your system to meet your needs. But at the end of the day, if you have questions throughout any of that process, we are here to help. So I'm going to turn it over now to our program manager and heat pump specialist, Christopher Harenga, and he's going to dive into some of the technical details of heat pumps and really provide a primer on what you should be thinking about as you move forward and give you a sense of the types of conversations you may have with Abode if you ultimately connect with us as part of the consultation process. So Christopher, turn it over to you.
Thanks, Travis. Yeah, so like Travis said, we're going to take a look at heat pumps in a bit of detail now. So let's start with how do heat pumps work? So a heat pump is a versatile, efficient cooling and heating system that operates using electricity. Heat pumps do not burn any fuel, they move heat from one place to another. To provide heat, a heat pump works by extracting heat from the outside air of your home and transferring it to a refrigerant, and it can do this even when it's very cold outside. The refrigerant is then compressed, which increases the temperature significantly. The hot refrigerant is then moved to the indoor unit of the heat pump, which then passes air over the hot refrigerant and transfers it to the indoor air. When in cooling mode, a heat pump and an air conditioner are functionally identical, absorbing heat from the indoor air and releasing it through the outdoor unit. When in cooling mode, the refrigerant moving to the indoor unit of the heat pump is very cold, transferring cool air to the space. Next slide, please. All right, so let's take a look at operating costs of heat pumps in RMLD service area. This chart uses RMLD's residential cost of electricity per kilowatt hour to represent the operating cost of an air source heat pump during the heating season. It uses 15 cents per kilowatt hour as the all-in rate for residential customers, including the NYPA credit and prompt payment discount. So heat pumps are 2 to 4 times as efficient as a gas furnace, even in the coldest climates. This technology has come a long way from traditional electric heating and offers efficiency that fossil fuels cannot match. Air source heat pumps deliver heat at progressively lower costs the warmer the outdoor temperature. So as you can see in this chart, we spend about 80% of our heating season between 32 degrees and above, and only 20% below freezing. The overall average of the season is represented by the green bar with the arrow. The bars following it to the right show the cost depending on the outdoor temperature. So as you can see, it's highly cost competitive against all other fuel types and nearly matches natural gas. While some customers opt to keep their existing system for days when it's extremely cold, many households will use heat pumps year-round and are still very comfortable. Noting the value of cooling as well, air source heat pumps are extremely efficient at providing cooling in the summertime. On average, heat pumps are twice as efficient as window ACs, and many models offer improved efficiency over central air as well. So a few key points to remember. The first one, air source heat pumps operating cost is cheaper than oil, propane, wood pellets, and electric resistance. And second, the cost of electricity is much more steady and predictable compared to fossil fuels over time. Next slide. And this chart here examines how many tons of CO2 emissions heat pumps versus traditional systems create over the course of 20 years, more or less the lifetime of any product. Including emissions from the fuel, heat pumps have the lowest emissions. However, heat pump operating emissions are technically indirect, you might say. Air source heat pumps have no direct emissions from the operation of the unit itself, whereas fossil fuel systems burn fuel at the unit and have direct emissions from operation. This chart uses New England's electricity generation mix to calculate emissions for heat pumps. The cleaner the electricity is produced, the cleaner the air source heat pumps will become. If you are purchasing solely renewable energy or have enough solar at your house, your operating emissions will be zero. RMLD's electricity generation mix is even cleaner than the representation above, so operating a heat pump in RMLD's service area will have even lower emissions. Plus, another nice thing about being a customer of a muni-light plant like RMLD is they have the opportunity to be more progressive and expedite the adoption of cleaner energy versus larger entities. The Rocky Mountains Institute recent analysis showed that in 2020, replacing a gas furnace with a heat pump will reduce carbon emissions in 99% of US households. And when compared to fuel oil, heat pumps are always cleaner. As the US electricity system relies more on renewable energy, such as solar and wind, this advantage will only grow. So a few key points from this section here. Energy production is getting cleaner every year, which means heat pumps' carbon emissions are reduced year after year as well. And heat pumps over the lifetime of operation have the lowest emissions. Next slide. So we're seeing a real diversification in the kinds of configurations of air source heat pumps. So I want to go through that a little bit today. So air-to-air heat pumps, or heat pumps that use the air outside to heat or cool the air inside, are the biggest market share today. So this has been driven by the growth of ductless air source heat pumps, or ductless mini splits mainly. That's probably the one that most people are familiar with, and we've seen in homes, shops, or restaurants in the area. But that is just one of the configurations that you can use in the air-to-air category. You can use more traditional centrally ducted systems. You can use one-to-one systems that are just one outdoor unit with one indoor unit, like a ductless mini split. There are even multi-zone systems now that you can match one outdoor unit with multiple indoor systems, and there's everything in between in terms of combining the different indoor units, and we'll talk about that in a moment. And so a few more reasons why air-to-air is the leader. The install for ductless units is quick and relatively straightforward. They're versatile and compatible enough to work in most homes to offset or provide all of your heating and cooling needs. And they are the lowest cost to install compared to many other types of heat pumps. They're also air to water. So this is another opportunity out there. So using the same technology, but transferring heat throughout the home with water, with hydronic systems that use baseboards, radiators, or radiant floor heating. There are a lot of really cool opportunities out there with new construction, but some challenges on the retrofit side with retrofitting existing hydronic systems. The hot water generated by air-to-water heat pumps is not as hot as the water generated by traditional boiler systems. The lower temperature water from air-to-water heat pumps requires a different type of hot water baseboard or radiator to keep the house warm enough when it is cold outside. So it's not always a good fit when trying to replace your boiler, but you can still consider air-to-air heat pumps as an alternative. As heat pump technology develops in the years ahead, we will likely see this becoming more of a possibility though, so keep your eyes out. There are also types of heat pumps more on the water side, such as geothermal or ground source heat pumps. Similarly, you're harvesting energy from the ground or from the water, and you can distribute that into your home in multiple ways, whether you're doing it through air handlers or through hydronic systems. So there are a lot of ways to mix and match this technology depending on your needs and preferences. But today we're focused on air-to-air systems. So now let's focus some more on the types of indoor units you can use with air source heat pumps. So ductless units are versatile enough that you can size them to heat and cool large open areas or even small bedrooms or offices. There's a lot of form factors when it comes to the ductless systems as well. So starting with the wall hung unit on the left that most of us are familiar with. You can get a floor mount unit that looks a little bit more like a floor radiator, at least in where it would sit, and then the ceiling cassettes that go in the ceiling. The bottom picture in the ceiling cassettes category is a bit of a newer product that does a better job of fitting between the joists in the ceiling, which was previously an issue in terms of fitting some of the ceiling cassettes. Again, there are always new technologies coming out all the time to make installing this technology very practical. Next slide. We're also seeing more and more ducted systems, mini ducts and compact ducts. We've got a lot of different names, but essentially the mini and compact ducted units can be set up with some amount of short-run ductwork that allows you to use one unit and impact a few different smaller rooms. These can be really handy to use in parts of a home where the bedrooms and bath are located so that each room doesn't require a ductless unit. These units are growing in popularity, but the industry is still more comfortable with centrally ducted units at large. And we're here to help you find the right contractor if these make sense for your home. These units range from the low static product on the left that can only probably serve 1 or 2 rooms to a higher standard product that can serve a whole floor or maybe 3 to 4 rooms. And finally on the right, a more traditional high static centrally ducted product that can service a whole house potentially. You can see here there's a lot of variety on the design side that you can leverage to find a solution that makes sense for your home, both functionally and aesthetically. And you can mix and match what you have in your house and find a design, or well, a design that's growing in popularity is to utilize a compact ducted unit for the bedrooms, bath, and hallway part of the house, and a ductless unit to serve the more open living area of the home. So there's all kinds of configurations you can utilize to try to find something that makes sense for your home. Next slide. So it's important to articulate your goals and motivations to a contractor well, so that in turn you can get a quote for a system design that meets your needs. So thinking about it, is your goal to save money, to increase comfort, to reduce your carbon footprint by reducing fossil fuel usage? How much of the home are you trying to heat? Do you plan to keep your existing system? And if so, how do you plan to use it? If you plan to heat and cool a substantial portion of your home with air source heat pumps, it's important to ask your contractor if they will run heat load calculations rather than use rule of thumb. Sizing heat pumps correctly from heat load calculations reduces the risk of performance and efficiency issues. If you keep your existing heating system running in tandem with an air source heat pump, it's important to consider how the existing heating zone will interact with the area the heat pump will condition. There are a number of good strategies to address this, including integrated controls, as Sean was mentioning. Integrated controls are thermostat systems that can talk to your heat pump and your existing heating system. If integrated controls won't work for your specific scenario, there are other ways to stage the existing system and the heat pump so they work together instead of compete with each other. Next slide. So yeah, as we've learned a little so far, there are many ways to design these systems to meet your needs. You can leverage the different types of indoor units to match the needs of your space you want to condition. So open floor plans work great with ductless units, and 1 or 2 heads can condition a large area. Compact ducted units can service areas with isolated rooms like bedrooms and bathrooms and hallways, offices, etc. And small single zone units are great supplemental heating and cooling additions to cold or hot areas of a house that you can just never seem to get comfortable. You can connect multiple indoor units to one large outdoor condenser, or break it up into multiple smaller outdoor condensers to improve control and efficiency. Next slide. So as I hinted on the previous slide, there are some pros and cons of single zone versus multi-zone units. Single zone or one-to-one units are incredibly efficient at both heating and cooling. The outdoor condenser can connect to a ductless unit as shown, or a ducted unit. Depending on the size of the outdoor condenser and the type of indoor unit, you can condition a very small room to a whole floor. Single zone units offer excellent control and comfort and are very versatile. Multi-zone, or 1 to 3 as shown in the image above, can also be connected to ductless, ducted, or a combination of indoor unit types. Still providing excellent efficiency when heating or cooling, these units can handle multiple rooms, floors, or the whole house depending on how they are configured. While one multi-zone unit could be configured to have enough indoor units to provide a solution to the whole home, manufacturers encourage best practice designs that break up the responsibility to multiple outdoor condensers rather than one. This can increase efficiency, control, comfort, and reduce the risk of any performance issues. Next slide. So as we continue to learn, air source heat pumps can come in a variety of shapes and sizes, configurations, etc. And so depending on your home's needs, the design that is appropriate for your home, and the goals as the end user, the cost can vary greatly. For small ductless systems that may serve a small to medium-sized room, you may see a cost in the realm of $3,000 to $5,000. For systems that are designed to service the entirety of a large home and provide all of your heating and cooling needs, and may include installing some ductwork, costs could exceed $30,000. So it really depends on what you're trying to do in the house, whether you're going ducted, ductless, the home size, what your goals are, etc. So it's also important to remember that your operating costs afterwards will vary depending on the system design and the outdoor temperature we discussed in previous slides. So if you're looking to displace oil or a propane system, you're likely going to save money. If you're looking to displace a moderately efficient natural gas system, your operational cost during the heating season might be minimal. Next slide. So heat pumps are different than traditional systems like boilers or furnaces, and there are a few things you may need to unlearn about how to operate them effectively and get the most out of your new investment. So I have a list here of things you don't want to do. So don't worry about the temperature reading. A heat pump measures ambient room temperature differently than your old heating system. So set your heat pump to a comfortable temperature, then adjust the setting up or down over the course of a few days until you've reached the temperature that feels right to you. In the area you're using your heat pump, you could try to turn your old thermostat 10 degrees lower than you used to. If you used to set it at 68, turn it to 58. This allows your old system to become the backup heating source. If the area gets chilly during a severe cold snap, don't be afraid to turn up the old thermostat temporarily. This way, you can maximize the use of your heat pump and see how much it can do. Try to keep the doors open to rooms without the ductless unit, allowing the heat pumps to circulate as much as possible. And don't fuss with it every day. You may have lowered the temperature on your old heating system when you went to work or at night. A heat pump is different. It reaches peak efficiency by maintaining a set temperature. Find the right setting, then leave it alone and let it work. There are exceptions though. For absence of over 24 hours, go ahead and turn it down. And 3 here, don't go easy on your heat pump. The best way to benefit from a heat pump's superior efficiency is to use it for as much heating as it can handle. Experiment by opening a few doors to expand the zone and then turn up the fan. You might be surprised how much space a heat pump can actually heat. Don't use auto mode. So it's natural to think auto mode would be a more efficient setting, but if you use it, your units may run the risk of toggling unnecessarily between heating and cooling. Your heat pump will run most efficiently when set to heat in the winter and cool in the summer. But also note the auto fan function is a separate setting and is totally fine to use. Don't use the lowest fan speed. Strange but true, a heat pump works most efficiently when set to a higher fan speed. Of course, high fan speeds can produce more ambient noise and air movement. Use the highest fan speed. Hire a qualified professional to service your heat pump every year or two, and you can see your heat pump's manufacturer guidelines for the maintenance interval. And last year, don't worry about an ideal swap over point. And so what's a swap over point? It's the exact temperature below which it would cost less to run your backup system than your heat pump. But it's not easy to figure out since it depends on backup fuel, the heat pump model you have, electricity rates, and many other factors. So use your heat pump as much as possible. Unless your backup heating fuel is a very affordable one, like natural gas, there aren't enough super cold hours in the year for your heat pump in a cold weather to make the swap over point really worth worrying too much about. So these tips we just covered help increase efficiency and operating costs. It's important to understand how your new heat pump works and how to operate it efficiently to get the most savings out of it. Next slide. So as part of this program, we curate a participating contractor list. There are lots of contractors in the community, and despite our best efforts, they may not be on the list. We're here to engage with them and explain how to file for the rebates. So we're not directly endorsing any contractors, but contractors on this list have passed an application process. We check to make sure they have attended relevant manufacturer trainings for the products they installed, checked references on their work, and they've committed to provide high quality customer service to operate in this program. They are also familiar with the pre-approval and install QA steps of the rebate process. So customers are not required to use contractors on the participating contractor list, like Sean said. As long as the pre-approval and install QA steps are followed by our contractor, you can still receive a rebate. Just a reminder as well, contractors on the list are already familiar with that process. All right, next slide. So in order to receive your rebate, your contractor must submit those pre-approval form prior to installation and an install quality assurance form after install is complete. So the pre-approval form is where the contractor submits information about the home and the system plan to be installed. So when we receive the pre-approval form from the contractor, we'll consider the first 3 things there on the left. Is the equipment reasonably sized for the space being conditioned, the type of floor plan, and the building envelope? Is the equipment selected appropriate for the type of floor plan and intended use? And are we optimizing runtime and use? If all those make sense, we would approve the project. Install QA is used to ensure systems meet best practice installation guidelines for cold climate air source heat pumps. They'll provide us key photos of the installed equipment and site conditions and respond to attestation questions regarding the steps of the install. And at the end, surveys are used to ensure participating contractors are continuing to provide great customer experiences, and we strongly encourage customers to complete them. So with that, I'd like to pass it back to Joyce for the Q&A.
So we have a few questions here. A couple questions about heat pumps working at colder temperatures. A question here, how well do these systems work at 25 degrees and below? And does it work as efficiently as natural gas in colder temperatures? That would be Christopher. Maybe you could answer that one.
Yep, jumping in. So yeah, absolutely. These systems can operate down to even temperatures down into the negatives. It just depends on the model that you choose to purchase. And so different models can do different things and they're better at different things. So generally you can, if you're looking to buy a system that will be able to provide heating to your home, you know, all the way down to the coldest temperatures we see here in New England, you can certainly go out and buy a heat pump that can do that for you. These systems will still be operating at efficiencies higher than natural gas furnaces or boilers can achieve. And with that in mind, as far as cost saving goes at that point, it just kind of boils down to how expensive is the natural gas, how expensive is the electricity, looking at the efficiency of each system, and you can do the math to figure out, you know, what that ideal swap over point is. But like I pointed out, there's so many factors to try to figure out exactly where that point is. It's usually best just to try to maximize the amount of time your airsource heat pump is running, to try and reduce your carbon impact as much as possible, and still just, you know, make sure that you're remaining comfortable in your house.
And one additional comment to that, if I may, the home itself and the building envelope matter. And so if you have a leaky home and you're putting in high efficiency equipment, it's still going to be running a lot and you still might not achieve the kind of comfort and savings goals that you're hoping to. And so it is really important when you're thinking about making any improvement along these lines that you are thinking about your home as a system. You're thinking about the fact that regardless of what you're heating it with and how you're heating it, your home is going to be losing heat during the wintertime. And so the more you can do to insulate and air seal your home, the better. And that's going to improve the efficiency of any system that you have in place. And with heat pumps particularly, you know, making sure that we are combining the improvements of the equipment itself with any kind of thermal improvements is an important piece that we encourage folks to consider and take advantage of any incentives or rebates that are out there, whether that is through the Mass Save program if you're a National Grid gas customer, or if you are here in RMLD and are able to leverage any incentives on the weatherization side. So that is part of what we will aim to speak with you about during the consultations as well.
Great, thank you both. So someone's asking if customers can install heat pumps themselves without using a contractor. So, oh, John, go ahead. Yeah.
Look, I can take that, and others can chime in. One of the requirements of the program is that it needs to be installed by a licensed electrician. So what is the reason for that? The reason for that is we want to make sure that it's a safe installation, that it meets the requirements, the code requirements of the state and the town. The other is that if you read the fine print of almost, and I think all of the manufacturer's warranty, is that they do require it to be installed by a professional contractor.
Great, thank you. I have another question for you, Sean. Someone's noticing that on our heat pump program requirements on the RMLD website, there's a limit of a CEER, which is seasonal energy efficiency ratio of 16. They're wondering if anything lower would qualify for the rebate.
Unfortunately, it doesn't. So this begs the question of why was 16 chosen? That's a really kind of a critical threshold minimum for the high efficiency in terms of what we're seeing in the industry. So that seems to be really kind of the benchmark that we wanted to hold up to.
Great, thank you. Another question here on other rebates. So maybe Christopher or Travis, you can answer this. Are there other federal tax credits for air source heat pumps available currently?
Travis, you want to take that one or me?
Yeah. So the short answer is yes. They are not very generous, and I would recommend that you consult with your tax accountant to confirm eligibility on those. But yes, there are, and I don't know the exact amount. I think it's $300 or $500. Christopher, do you know for sure?
It's around there. Yeah, it's not too much.
Yeah. But again, I think working with your accountant just to confirm. But there are actually, I mean, there are many different federal tax incentives for home energy improvements. There's a list of different improvements that one could be making to then file or to use as part of your tax filing. But I would encourage folks to work with their tax accountant on that.
Great. A question for Sean. We've had a few of these questions. Does RMLD offer any rebates on insulation or efficiency improvements for the whole home?
Currently, we do
Envelope.
not. We do not. That is something that we've talked a lot about internally. As we get a little farther into 2020 or 2021, that's something that we're going to consider to determine if we can add that to our suite of programs. But right now, we do not offer any.
Great. Thank you. Someone's also asking about distance requirements for the outside unit of the heat pump. So maybe Christopher, you can ask this. You know, should it be away from other pipes, and you know, are there specific restrictions on where you can put those outside the outdoor unit?
Yeah, generally you can be very flexible with that. I think you just want to be mindful of a few things. You know, when you are installing these units, you want to make sure that you can have some ground clearance there so that they don't get buried when we get a lot of snow like we recently have. They do make a little bit of noise. They're not very noisy by any means, but they're right outside your bedroom window, right by where your head is, by your bed. Maybe try to locate it somewhere slightly different. So things like that you might be mindful of, but generally, you know, where the fan is blowing, etc., from these condensers, that might be the only consideration to think about, is where that air blows. If it's blowing on like a precious outdoor plant or something that you want to make sure that you don't get too much air blowing on it throughout the year, maybe avoid that. But otherwise, yeah, there's not too much to worry about.
And I did see one of the questions around that was a concern about siting near a radon exhaust pipe. So just to clarify, the heat pumps themselves are not physically moving outside air into the home. And so that is, I think, maybe the source of that question. So, you know, with your radon exhaust pipe that is pulling radon from the foundation and exhausting it above, typically the roof line, there's no concern there on that end. I would second Christopher's comment about siting it near kind of windows or a bedroom. Our unit is immediately on the outside wall of our bedroom, and occasionally at night I'll hear it, but they do operate at pretty low decibels, lower than a central heat pump, significantly lower than a central heat pump, or central AC rather. But you can still hear them from time to time, so that is a good consideration to have in mind.
Perfect. And similarly, someone's asking about asbestos on the side of their house. Would they have to get that kind of thing remediated, or can they install a central air pump system without worrying about that one?
Right. So, I mean, in New England, there are a lot of homes that have asbestos siding, and there are a lot of contractors that are licensed to work in that type of situation. So there are no requirements on our end. I think that it is important, if that is something that is true for your home, that you have that conversation with your contractor to ensure that they are going to be operating in a safe way with that situation. But that is not necessarily a barrier that can prevent moving forward with this when done properly and safely.
Great. I have a question. I think this one would be for Christopher. Can the outdoor unit of a heat pump be installed on rooftops for second floor heating?
Like if it's on like a pitch roof or something, I'm probably not. You know, if you have a flat roof, like if you're on like a brick building or something with a flat roof, I could see that being a possibility. But generally, these units are placed on the ground on a mount. You can also mount them to the side of the home. You don't really want to put them up too high because you want to be able to maintain the unit. So you don't want to have to break out a 20-foot ladder to get up there to, do some work on it. But generally, yeah, they're usually located on the ground or mounted on the outside of the house.
Great. Thank you. And then another question here about integrating heat pumps with existing air conditioner systems. So would the outdoor air conditioner condenser need to be replaced as well, or could those somehow be integrated together or used? Could the condenser be used for the air pump heat system?
In that case, you would have to replace the outdoor condenser in order to be able to switch over your indoor setup to have it work with the heat pump. You may also have to change what you have inside the house there for your air handler. And depending on the condition of your ductwork and the sizing of it, there may also need to be some adjustments made to your ductwork. So there's a bit of consideration there, figuring out if that's a possibility, but that's definitely why you can work with us to try to figure that out and get lined up with good contractors that can help you figure that out as well.
Great. And then another question for you, Christopher. I know you touched on this a little bit in the presentation, but you mentioned heat load sizing versus typical general sizing. Is there a standard for what approved vendors should be doing to better size the system for your home?
Yeah, you specifically what it's called is a manual J. And so those are heat load calculations. There's a lot of software out there that runs manual J calculations. So that's the type of calculation we're talking about. And then you can also run something called a manual S to figure out what size equipment you should pick.
Great. Okay, Christopher, I'll give you a little bit of a break here and turn over to Sean. So do I need a town building permit prior to an inspection and after installation for a heat pump system?
The short answer is yes. As part of the program, you will need to have a wires inspection, which is part of the town permitting process.
Great. Another question for you, Sean. Can RMLD customers combine RMLD incentives and DOER incentives, or can you only get one or another?
They are separate programs, so you can piggyback onto those to the extent that your equipment qualifies for both programs.
And to clarify as well, one of the questions there was around the alternative portfolio credits, or the AEC, alternative energy credits. That is a tool, is a marketplace where folks can buy or sell into credits for alternative energy. So heat pumps do qualify when they're whole home systems, but because of legislative changes that have happened over the last year or so, the actual kind of market value for those has oscillated pretty significantly. So we don't encourage residents to kind of expect that. There are third-party kind of purchasers of those types of credits that folks can explore, but I certainly would not want someone to move forward with the heat pump with the expectation that they're going to be getting that, just because the marketplace is pretty it changes a lot and it's not very reliable right now. But to the degree that if there are any additional incentives that you might be available for, that is an area where Abode would try to help answer any questions that you might have and make sure that you're able to leverage those to the fullest potential.
Great, thank you, both of you. And then another similar question, do these heat pump systems through RMLD also qualify for the Mass Save interest-free heat loan?
So the Mass Save program is separate from RMLD. So in the 4 towns that we serve, we are the electric provider. And so all the electric programs and funding sources go through RMLD and not Mass Save for electricity.
Right, thank you.
If you have natural gas currently
true.
through National Grid, you would be eligible to use the heat loan though.
Great. Okay, we have another question here about someone who installed a central heat pump with integrated controls in 2017, and they're finding that the set point isn't working very well in their thermostat. And is there any suggestion to make the system more efficient or have the installation reviewed?
Yeah, I would say we're happy to work with you to answer any questions that you might have. At the end of the day, I think that, you know, taking that back to your contractor is likely your best bet if you haven't done so already. One of the things that, you know, we found is that especially the contractors working in this area have been very responsive to customer needs and questions. And so we would fully expect that, you know, your contractor would be able to kind of help resolve that if they haven't attempted to already. But I would start with them, but certainly we're here to help out and answer as best we can.
Great, thank you. So someone's wondering if they can install a heat pump in a garage. Maybe Christopher, you can answer that one best you can without seeing the garage.
Well, I'll also pass it to Sean afterwards. So if that's like a workspace or something that it's like your workshop's in there, I have seen people do that, and you'll just want to make sure, like Travis was mentioning, if that space is totally uninsulated and you expect a heat pump to try and keep it warm, and you're going to be opening and closing the garage doors a whole bunch and things like that, you might find that the heat pump has a hard time maintaining the temperature you're looking for in that space. So you might want to consider, you know, insulating it, you know, keeping the garage doors closed and not, you know, opening them a whole bunch, shutting them a whole bunch, things like that. It could be hard for the heat pump to keep up. I do want to, you know, just verify with Sean that is something like that, something RMLD would incentivize.
Yes, so technically they would be eligible, but I would also kind of reinforce what Christopher said in terms of looking at what the kind of the thermal envelope characteristic is of that space and how you're going to use it to make sure that it really is going to give you the heating and the cooling that you want in that space.
Great. Then we have another question here about maintenance of the heat pump and lifetime of the heat pump. I know, Christopher, you said we should be, you know, looking at the manuals and checking that out for how to maintain the heat pump system. Someone's wondering if they're using the heat pump, if you're using heat pump heating, does it reduce the lifetime of the internal unit because it's running on a lower temperature heat?
Yeah, so heat pumps are built, you know, very, very sturdy. They're meant to last a long time. And as I said before in that don'ts section, don't go easy on it. Push the thing and see how much you can get out of it. They're really built to last, and they should, as long as you continue to take care of them. And yeah, as far as what the maintenance interval is, you should check with what the manufacturer says you should do, and get the cleanings, get the servicing done. For the indoor units, if you have ductless units or ducted units, cleaning the filters as, you know, frequently as the manufacturer recommends, or as frequently as you kind of realize you need to, depending on if you have a lot of pets in the house, things like that. It might be more frequent than somebody who doesn't have any pets. So it's different house to house, but yeah, just follow the maintenance guidelines and they should last a long time.
And one additional comment on that as well, the part of that question I noticed was just around the concept of the heat pumps running continuously and not wearing the systems out. Kind of taking an analogy from a car and thinking about, you know, how we all know somebody who has a 80-mile commute or whatever, and they've been driving that same Honda Civic for 300, 400,000 miles because it's all on the highway and they're just cruising, versus folks that have the same type of car and they're in Boston driving every day 12 miles, and that car gets worn out quicker because it's starting, it's stopping, it's starting, it's stopping, and it's just kind of having to do a lot more work. Heat pumps really do operate in a very similar fashion. Getting them running at their steady state, kind of their cruise control, is going to really mean that it's going to have less wear and tear. So even though it might be running kind of on a longer duration throughout the day, the pace that it's running is kind of optimized for its performance and its longevity. And that's part of what we are going to be working with contractors and customers on when we're thinking about the sizing of these systems. So when we think about a system that is significantly oversized, that can actually kind of result in that starting and stopping to a detrimental degree. And that's where we want to be sure that, you know, as we're thinking about these things, and when you're talking to your contractors, making sure that they are doing the proper manual J and load calculations, and they are sizing a system that actually fits your needs and isn't, designed to fit a house that's twice the square footage, because that's actually counterintuitive to what we might be thinking about with kind of conventional HVAC. Oversizing these systems can actually cause more harm, not only for the systems themselves, can cost you more money on the operational side, and can wear the systems out quicker. So getting the system sized the right way will actually help them run longer and run more continuously, which is how they are designed to be operated.
Great, thank you very much, Travis. Another question here. If one has oil, heat, and central air, would it generally be advised to replace both with a heat pump, or just heating, or just cooling? Maybe Christopher, if you want to.
Yeah, I think it depends on your goals there to think about, what you want to do. Why do you want to switch over to heat pumps? What are your motivations? And think about that. And, especially how the house is designed as well. It might make sense to just start small and only do like a ductless unit in the open living area of the house. Start there, see how that works. And then over the course of a few years, maybe adopt something else that might replace your AC condenser outside. There's a lot of variability, a lot of options. You don't have to feel like you need to do everything in one shot in the house. You can start small, and that's a great strategy to try and approach the design in your home. So it's easier to figure out, what you need where as you go along. But yeah, if you want to talk specifics about your house, by all means, feel free to set up a consultation with us.
Great. And then another question here. I like to open windows in spring and fall and sometimes summer. Does that make it more difficult for the heat pump to regulate the temperature? I think we are all excited to have windows open again. Christopher, do you want to take?
Yeah, I think with any type of HVAC system you had, it would make it a little bit harder for that system to keep up with what you were doing. With that in mind, I think when it's nice, beautiful day outside and you want to open your windows and you don't mind what temperature is it outside and that air coming in, I do the same thing. And just try to be mindful of, if it is going to be getting, colder at night, maybe shut the windows so that the heat pump can keep the house warm, etc. Or if it's in the summertime, the opposite. So just try to be mindful of what's going on outside so that you can make sure that you don't, cause the system to have to run really hard for a long period of time and decrease your efficiency, maybe run up your bills, that kind of thing. But I think that question would go the same for whether you have just a regular AC condenser or an oil boiler or heat pumps. It's just kind of something you want to be mindful of no matter what type of HVAC system you're using.
Great. So if we have natural gas, someone has a natural gas furnace and window air conditioning. And they're wondering if they're likely to see savings if they primarily use the heat pump for cooling only. So if they're switching from a window air conditioner to heat pump cooling.
Yeah, so heat pumps are generally about twice as efficient as a window AC unit. RMLD does want to see folks using these systems for at least shoulder season heating in order to provide the rebate. So, it is to hopefully incentivize folks to stop using fossil fuel to reduce the carbon impact there. So we do want to see people using these systems for at least shoulder season heating. So cooling only setups are not going to be rebate eligible.
Great. This one, I guess, for Sean. If you've started small with one unit, as Chris mentioned, would you be eligible for further rebates if you chose to expand in the future?
Yes, absolutely. The only limit is we do for a given zone in your home, you would not be eligible to replace that for 12 years. But if you expand it to the rest of your home, to other zones, absolutely, you can reapply. We've actually had a couple of customers so far that have done that.
Great. And then I have two questions here about recommendations for makes or models for cold climate. So someone's asking if you have a recommendation for a make or model for a centrally ducted heat pump in cold climates that operate below 20 degrees Fahrenheit. And then another one recommended low outdoor temperatures when using a heat pump for auxiliary heat?
So we have to be impartial here. We don't recommend any specific brand or model of any manufacturer out there. I think a great place and a great resource to use as a consumer or a contractor is the Northeast Energy Efficiency Partnership's cold climate air source heat pump specification list. That was a mouthful, but if you go to Northeast Energy Efficiency's partnership's website, you can find that list, or with a quick Google search, if you can remember everything I just said there. But yeah, it's NEEP for short. And if you Google their cold climate air source heat pump list, you should be able to find that. And that's a great resource to fiddle around with and try to find a system that you like.
Great. Okay. So we have a question about whether you could run a heat pump. How would you run a heat pump to take best advantage of time of use electric rates and help with shred the peak efforts? Or if that's even possible to run a heat pump in that kind of way.
Yeah, so I'll take a first stab at that one. So again, we've talked a lot about the best way to operate a heat pump is to get it to your ideal comfort level and then just let it run. And that certainly is still true as it relates to the kind of time of use rate, mainly because if you are turning the systems on and off, you are going to have a greater draw from that system trying to catch up to get back to that comfort level that you've set. And so that can be kind of a challenge. You know, these systems do have a maximum kind of draw, so it's not, you shouldn't necessarily expect an astronomical increase, but on the savings side, that can be something that you should be aware of. On the shred the peak efforts, and I know it's certainly welcome, Sean and others from RMLD to chime in here. The options here, I mean, I think that just by the fact that you're using a heat pump versus electric resistance, or in the summertime when we have peak events using a window AC unit, you're already going to be kind of contributing to part of the solution. That is one of the reasons why RMLD and other utilities actually incentivize these systems, is because they actually do help in the overall load management during peak events. But I wouldn't necessarily recommend, unless it's a pretty significant event, turning off the system per se. But Sean, do you have any advice for folks in that scenario?
Really, just to reiterate what you said, in terms of operating it on time of use rates, the savings is really what you're offsetting, like the resistance heat or the inefficient window AC. But really, these technologies are designed to just run like the highway example for the car. So it's not like with your EV where we encourage people to charge, in the middle of the night. With heat pumps, they operate the best when they are run. So it's a little bit kind of different in terms of how we would say to manage it.
Great. So I have a question here about comparing heat pumps and traditional air conditioning. So maybe Christopher, you can answer this. So in regards to cooling, how does a heat pump's operation differ from traditional air conditioning? It seems to function in a very similar way, and my central air conditioner uses a whole lot of electricity. How does a heat pump use less?
Yeah, so they operate functionally the same way. A heat pump is able to reverse that cycle and instead, provide heating into the home. The technology has just gotten better. The way that they can, the amount of heat or cool they can extract out of the refrigerant that is running between the condenser outside and your indoor unit has gotten more and more efficient. And that's why, older AC systems, they didn't have as high of what they're called SEER ratings. And compared to heat pumps now, that SEER is a lot higher than they used to be, and they can provide the same amount of cooling for much less energy usage.
Okay, thank you, Christopher. So we have two questions about pricing. And of course, it is hard to know without knowing the whole house and system, but what is the price range if you already have duct work and want to get off of oil and move to heat pumps for the whole house, air conditioning and heat? And then another question, what kind of cost difference is there when replacing one systems versus two?
I can't really say specifics. There's so many variables that go into that. Is your ductwork good enough? Does it need adjusting? Does it need to be replaced, et cetera? There's so many things that go into that, the type of system you end up purchasing, how big it is, all sorts of things. So I would say feel free to set up a time with us to chat. You can get some contractors in the house. Doesn't hurt to get a quote. At least you can kind of see what numbers you're looking at that point.
Great, thank you. And then looks like the last question here, unless anyone has any more. If a wall unit in a garage is near wood shop dust, would that be an issue? And would there be better filters you could use, or could you replace or change filters?
Yeah, I would suggest trying to locate it somewhere that wouldn't be near anywhere that has like a lot of dust, or like right above your stove where there's a lot of like oils and things. Generally, locating these systems a little bit away from locations like that is better for the filter and the indoor unit itself as well. So be mindful of where you want to locate the indoor units. If they're near areas like the wood bench where there's going to be a lot of sawdust potentially floating around, that would clog up your filter pretty quick and have to clean it all the time. And it might get into the unit farther if you're not keeping up with cleaning. So generally keeping them a little bit farther away would be ideal.
Great, thank you. Okay, so a few more questions are trickling in. So heat pump efficiencies have improved over time. Is it fair to assume that if I wait, they will be better still in the near future?
I'll take a stab at that one since Christopher's been talking so much. I mean, the short answer is sure. They have improved a lot. The nice thing about heat pump technology, though, is that kind of as a fundamental technology, it has just been around for so long. And as far as the application for air conditioning and heat pumps, this is not a new technology. This is not not something that is revolutionary in the sense that it just hasn't been happening. And there are parts of the world where this is kind of the only thing that they use, right? Just in the United States, because of our infrastructure and the times at which our houses were built, the decisions were made to go a different direction, right? I think that as someone who has a heat pump, I made the decision to do it because we needed a good heating and cooling solution for our home. And of all the options out there, I believe a lot of reasons that it was the right choice. I would encourage folks, if you're on the fence about it and trying to figure out if now you should do it or if you should wait, think about what benefits you're wanting to get out of it. Are you looking for those comfort benefits, the potential savings benefits from getting off of oil, as an example? And then, to Christopher's point, getting engaged with some contractors, getting some quotes, and really having somebody explore that solution so that you can have a real sense of, yeah, the technology is going to evolve, but to the degree that it's going to make leaps and bounds, I don't think that we're going to be seeing that, right? We're going to see kind of marginal improvements at this point. And so if it's something that you're interested in exploring, diving deeper into it and really taking the time to evaluate the benefits, as it relates to what it can provide to you with the technology where it's at now, I think is an important step. But yeah, the technology is good. It is effective in New England. I think there is a lot of concern that these systems just on the whole are not ready for Massachusetts, as an example. We work closely with folks all across New England and Maine and Vermont, where these are being installed, at flip rates, where people are putting them in for a variety of uses as whole home solutions, and they're doing quite well. These do need to be coupled and thinking about, as I mentioned before, kind of your whole home and whether or not you have a tight thermal envelope. But these systems are more than capable of serving the needs of New England households when sized and designed properly. And finding a contractor that you can trust, that has put in the steps and has gone through the process of doing the right calculations and evaluations, is still just an incredibly important part in finding a solution that will work for you at the end of the day.
Yeah, those are really great tips, Travis. Thank you. Then we have another question here about doing this in the pandemic, and can any of the required steps be conducted virtually? Or I guess some more clarification on what's done virtually, what's done in person, and that stuff. So Christopher or Sean, one of you can answer this one.
Well, all of our consultation is done remotely, so most of that is just done over the phone, and we can talk through what's going on at your house, chat about your ideas, and have a whole variety of different conversations depending on what your needs and goals are. Sean, is there anything else you wanted to add to that?
No, that's really it. You know, a lot of the documentation in terms of photos and things like that that are required, you know, are collected by the contractor when he's there doing the installation. So it's really not any additional in-home requirement or burden, especially, you know, given the times we're living in.
Great, thank you. And then I have another question, maybe for Travis. Do you offer blower door tests or efficiency tests, and can you coordinate that as an add-on service?
You're muted, Travis.
Gosh, I was hoping I could make it through this whole thing without doing that one. So yes, we can certainly help to coordinate that with you. There are a variety of folks that do provide blower door testing and can help to get that number for you if that's something that you're interested in. I'll also note that through RMLD, residents are eligible for a no-cost home energy assessment. Again, I mentioned before with the Mass Save program, if you are a National Grid gas customer, you can utilize the Mass Save program for the energy assessment and those incentives. And if you are not a National Grid gas customer, you can still access a no-cost home energy assessment through RMLD, which I think is a really great step in terms of thinking holistically about your home. And we'd certainly encourage folks to utilize that resource as it's made available.
Yes, thanks. That's very good to remember. And it looks like we don't have any more questions at the moment, so I will pass it over to Joyce.
Awesome, thank you. That was all really, really good information. So just to wrap up, as far as additional resources, we've mentioned our air-source heat pump guide a couple of times. There's some really good information on there. There's links to a lot of the things we've talked about tonight. We will send an email to all the folks who have registered for the webinar, and it will have a link to the air-source heat pump guide. There's some Northeast, and it is a mouthful, Northeast Energy Efficiency Partnership resources on the heat pump guide. And also, if you have specific questions or you want to pursue this further, there's a link where you can schedule a free consultation with Christopher to talk a little bit more about your situation, your specific situation. So that is it for tonight. So we thank you very much for spending the evening with us. You'll receive a follow-up email with that information and the recording. Hopefully next time we do something like this, it can be in person as opposed to via webinar, because I think a lot of folks maybe are a little bit tired of this venue, but we are very glad that you joined us tonight. And we hope that you stay safe, and we will see you next time. Take care.